Hey everybody, hope you're doing well. Hope you're working on Alex a lot, catching up on all the things that you might have missed. Um, we are working now on exam 2 review. Please be sure to log on to Alex, do the catch-up assignment, actually do the knowledge check, then the catch-up assignment. Right? And then once you've watched these videos, study by Friday at midnight. You have a 2-hour test to do in Alex. Right? Make sure you get that done before Friday night at midnight. I know it's Good Friday on Friday, so you have this whole week to catch up, get all of this done, and get that test done. My hope is, because I know a lot of you have to improve your grade for that third marking period to send to colleges. My hope is for you to get it done so I can count it on the third marking period so your grade goes up. I will be going over sections 1 or problems 1 through 14 on your exam review that I posted yesterday. So let's go. Number 1, all we have to do on number 1, it says find any values of the variable that make the expression undefined. These are called excluded values. So we have 4 over m plus 9. We're looking for values of m that make the denominator 0. So we're only looking at the denominator. We set that equal to 0, and we solve. So m equals -9. -9 would be an excluded value. It's an excluded value because when plugging in, it would make the denominator 0, therefore it being undefined. Number 2, we have x squared minus 9 over x squared plus 11x plus 30. For excluded values, our numerator doesn't matter, only our denominator. So we have to figure out what makes x squared plus 11x plus 30 equals 0. That's going to require some factoring. So we have to factor by finding 2 numbers that multiply to 30 and add to 11. That would be x plus 6, x plus 5. We set each of those equal to 0. And we solve down by subtracting 6 and subtracting 5 and figure out that -6 and -5 make the denominator 0. So our excluded values, x cannot equal -6 and x cannot equal -5. For numbers 3 and 4, we are asked to simplify these expressions. We have number 3, we have all binomials here. The rule for canceling out a binomial is it has to be the same exact binomial. You can't cancel out parts of it. So as long as you have the same binomial in a numerator and denominator, you can cancel it out. So we're going to cancel out y minus 5. So we're left with y plus 3 over y plus 8. Do not cancel out the y's here. Because the y is part of a binomial, you can't cancel it out. Your answer would be y plus 3 over y plus 8. Number 4, we have a monomial over a monomial. When it comes to monomials, you could cancel out individual parts of it. So we have 15 over 5 would be 3, and k to the third over k to the first would be k squared. So that simplifies to be 3k squared. And number 5, we have a trinomial over a trinomial. What we're going to have to do is we're going to have to factor the numerator and denominator. The numerator, we have to look for 2 numbers that multiply to -10 and add to 3. That is going to be +5 and -2. The denominator, we're looking for 2 numbers that multiply to -35 and add to -2. That is going to be y minus 7 and y plus 5. So we look at what we can cancel here. We can cancel out the y plus 5s. I'd be left with y minus 2 over y minus 7. Final answer, y minus 2 over y minus 7. Number 6, our numerator, a squared minus 25. That is a difference of two perfect squares. That is going to factor to be a plus 5 times a minus 5. The square root of a squared is a. The square root of 25 is 5. One positive, one negative. The denominator, a squared plus 7a plus 10. We go looking for two numbers that multiply to 10 and add to 7. That would be a plus 5 times a plus 2. A plus 5's cancel. Our answer is a minus 5 over a plus 2. Number 7, we have 4x plus 12 over 6x plus 18. You might not think there'd be a way to factor this, but we have to pull out the greatest common factor of each. So 4x plus 12, what goes into 4 and 12? 4, leaving us with x plus 3. Now what goes into 6x and 18 would be 6, leaving us with x plus 3. Now, the obvious thing here is that the x plus 3's cancel, and we would be left with 4 over 6. But we can't forget to simplify and reduce that fraction to 2/3. Okay. Number 8 is one of the more challenging problems. We have 9 minus m over m minus 9. What kind of sticks out in my mind is that this is reverse. 9 minus m. I want to rewrite that as negative m plus 9 over m minus 9. Whenever you have leading coefficient that is negative, factor out that negative 1. So that's going to leave us with negative 1 times m minus 9 over m minus 9. The m minus 9's canceled. We're left with negative 1. Okay, for number 9, I'm going to show you two different ways of looking at this. The most common way for you guys to go about this, and what you're probably going to do, is you're just going to, when we see all monomials, multiply it together. So we have 4 times 49 would be 196 x squared over 7 times x cubed. 196 over 7, put that into your calculator, we get 28. And then we have x squared over x to the 3rd. Where are there more x's? There's more x's on the bottom. How many more are there? There's 1. Our answer would be 28 over x. Another way that you might want to go about it is right from the beginning. I'll write it again. Instead of multiplying them together, see what cancels. I have 49 and 7. I know that 7 goes into 7 one time, and 7 goes into 49 7 times. Then I have an x squared. That would cancel out 2 of the x's down here, leaving me with an x. Then I multiply what I have left. 4 times 7 is 28. And in the denominator, I just have a 1 and an x, leaving me with x. Same answer, kind of two different ways, just multiplying first versus canceling out without multiplying. Now, number 10, we have pretty complicated. We have a trinomial over a trinomial times a binomial over a trinomial. What we have to do here is we have to factor everything. So k squared plus 14k plus 49 would factor to be k plus 7 times k plus 7. 7 times 7 is 49. 7 plus 7 is 14. K squared plus 16k plus 63 would be k plus 9 times k plus 7. K squared plus 9k is just a binomial, not a difference of perfect squares because I don't have a subtraction and I have that other k there. All right, so I have to factor out that GCF. So that's going to be k times k plus 9. And then k squared plus 11k plus 28 would be k plus 4 times k plus 7. Now we have to look to see what cancels out. As long as we have something in any numerator and any denominator, we can cancel it. So I see here that k plus 7 and k plus 7. Also the other k plus 7 and k plus 7 cancels. I see a k plus 9 and a k plus 9. And then we are left with, in the numerator, k, and in the denominator, k plus 4. All right. Once again, these k's cannot cancel because that k is part of a binomial. So we are done. Our last multiplication problem we have y squared minus 25 over 6y minus 30 times y plus 1 over y plus 5. Y squared minus 25, there's that difference of two perfect squares again. That becomes y plus 5 times y minus 5. Our denominator, 6y minus 30, we could factor this by pulling out a GCF and making it 6 times y minus 5. Then that's going to be multiplied by y plus 1. Can't do anything with that, over y plus 5. Now we have to simplify. I have a y plus 5 and a y plus 5, one in the numerator, one in the denominator, and a y minus 5 and a y minus 5. What am I left with? Y plus 1 over 6. Right. Moving on to division. We have division here. This is all monomials. Now, the one difference between division and multiplication is that we have to multiply by the reciprocal. So we're going to keep, change, flip. We're going to keep the first fraction as it is. Change the division to multiplication and take the reciprocal of that second fraction. So that becomes 20y to the 4th up top and 20x to the 3rd down the bottom. What I can do here is I can simplify this or I can multiply this together because we have here 20s. I want to cancel those out because I know they cancel out. So then we are left with 8 over 20. 8 over 20, 4 goes into each of those. So I would get 2 over 5. Then I have x to the 12th up top and x to the 3rd down bottom. That would be x to the 9th up top because there are 9 more x's up top than in the bottom. And then I have y to the 4th in the numerator and y to the 9th in the denominator. I have 5 more y's in the denominator than the numerator. So my answer would be 2x to the 9th over 5y to the 5th. Here we have another division problem. We have 2 rational expressions that are being divided. What I have to do is I have to factor everything and keep, change, flip. All right. I'm going to do it all on one step. You can keep, change, flip, and then factor in the next step. I'm going to do it all at once. So I'm going to factor the first numerator. So I'm looking for 2 numbers that multiply to 32 and add to 12. That's z plus 8 and z plus 4. Z squared plus 17z plus 72. I'm looking at z plus 9 and z plus 8. And that's going to be multiplied by, I'm going to factor the denominator and put it in the numerator. So we're looking at 2 numbers that multiply to 54 and add to 15. That's going to be 9 and 6. And then I'm going to factor the numerator and put it in the denominator because I am flipping that last fraction. That's going to be z times z plus 4. Pulling out the GCF there of z. Now what's left is I just have to cancel if it's the same in the numerator and the denominator. So I see a z plus 8. I see a z plus 4. I see a z plus 9. And I'm left with z plus 6 over z. All right. One more problem for this half. Last problem of the day is number 14. Save the second half for tomorrow. X squared minus 25. We have x plus 5, x minus 5. We are dividing. I'm factoring everything and keep change flip in the same step. So this is the difference of two perfect squares. Now we're looking for two numbers that multiply to 16 and add to negative 8. That is going to be negative 4 and negative 4. So I have x minus 4 and x minus 4. Division becomes multiplication. And then I'm going to flip this. So I'm going to factor x squared minus x minus 12 to be x minus 4 times x plus 3. And then I'm going to factor 10x minus 50 by factoring out a 10. That leaves me with x minus 5. Cancel similar things. I see an x minus 5 that cancels. 1x minus 4 cancels. And that's all I'm seeing. So what do I have left in the numerator? I have x plus 5 times x plus 3. And in the denominator, I have x minus 4 times 10. I'm going to write that as 10 times x minus 4. That monomial comes first. Nothing else can simplify. I'm done. I hope you enjoyed it. I got another one for you tomorrow. Make sure you're doing that knowledge check, that catch-up assignment, and you're prepared to take that exam. 2 hours. Once you start it, you get 2 hours to complete it. It's 24 questions. Any questions, let me know. Have a good one. Stay safe.